Hello friends, in today's question, figure given shows a block of mass m1 sliding on a block of mass m2 with m1 is greater than m2. Find acceleration of each block, tension in the string, force exerted by m1 on m2, and last is a force exerted by m2 on the incline. So this is the basic diagram. So m2 and this is a mass m2, this is mass m1. So let's draw the free body diagram of individual mass, and then we are going to find out the various forces that will be acting on them. So first of all, let us draw for m1. So this is mass m1, okay, and it is going to have tension T in the upward direction, okay, and it is given that m1 is greater than m2, so the direction of the motion will be in the downward direction this way, and let us suppose the acceleration is given by A. And it is going to have m1g rather, acting vertically downwards. This m1g can be divided into two components. One will be your mg cos of theta, so this will be angle theta. We are going to have m1g cos of theta, and this will be m1g sin of theta. Next, there will be a normal, and let us suppose we denote it by n1. Okay, so these are the various forces which is acting on the mass m1. So let us, and we take the this way as x-axis, and this is our y-axis. Okay, so let us divide it to various components. So we have a acceleration of A, so we can say that in the downward direction, okay, we can say that m1g sin of theta minus t will be equal to m1a. Let us call this equation number 1. And in the this was along x-axis. Along y-axis, we can say that n1 will be equal to m1 g cos of theta, and this is equation number 2. Okay, and here we can say for mass m1. Similarly, we can draw for mass m2 also. So this is our mass m2. It will be going to have vertically downward m2g, and it can be divided into two components. This is angle theta, so we have m2g cos of theta, and this will be m2g sin of theta, and we are going to have a tension T in the upward direction. And this m2 is going to have two normals. One will be because of mass m1, which will be having value of n1, and another one will be because of this inclined plane that we are going to call as n2. And there will be motion in the upward direction, as m1 and m2 are connected by a single string, so we can say it is also going to have acceleration a. Okay. So we can write, similarly we can write this equation for mass m2 as well. Okay, so you can say that t minus m2g sine of theta will be equal to m2a. Let this be equation number 3. And next we have two normals. Okay, we can say that n2 is equal to n1 plus m2g cos of theta, and this is equation 4. Okay, now we are subsequently going to solve all these 4 equations and find out the respective answers. Okay, so first of all, what we do, we are going to add equation 1 and 3 because we are interested in finding the acceleration a. Okay, what we do, we add excuse me, adding equation 1 and 3. So if we add 1 and 3, t and t are going to cancel with each other. Okay, on the left side we can write m1g sine theta minus m2g sine theta is equal to m1 plus m2 and a as common. From here we can directly get the acceleration equation. Acceleration will be equal to m1g sine of theta minus m2g sine of theta divided by m1 plus m2. So this is the acceleration of each block. Okay, because they are connected by the same string, so both will be traveling by the same acceleration. So we can say that this is acceleration of each block. The next part, we are supposed to find out what will be the tension. Okay. So we can use any of the equation, either equation 1 or equation 3, and we already know value of a. From this we can find out what will be our tension. Okay. So you can say that tension T is equal to m2a plus m2g sine of theta. Okay, and we already know value of a, so we put value of a is m2, a is given as m1g sine of theta minus m2g sine of theta divided by m1 plus m2 plus m2g sine of theta. So if you want, we can solve it further also. We can see that we have to take the LCM, and if we solve this further, we get tension as finally it will be coming as tension, it will be equal to twice m1 m2 g sine of theta divided by m1 plus m2. Okay, so this will be nothing but the tension in the string. Okay, we can say that this will be tension in the string. In the next part, we are going to find out force exerted by m1 on m2. Okay, force exerted by m1 on m2. So we already know the equation which states that m1 n1 is equal to m1 g cos of theta. Okay, we already have the equation, that is equation number 2. Okay, so we can say from equation 2 we have n1 is equal to m1 g cos of theta. So we have to find out the force exerted by m1 on m2. So we can say the force exerted by m1 on m2 is given by the normal n1. Okay, so it means force exerted by m1 on m2 is represented by n1, okay, which is equal to m1 g cos of theta. And in the last part, we are supposed to find out force exerted by m2 on the incline. So we are going to find out force exerted by m2 on the incline. So m2 and inclined plane are exerting on each other a normal n2. So the force exerted by m2 on the inclined plane will be nothing but its normal. Okay, we can say that force exerted by m2 on the inclined plane is n2, and we already know n2 from equation 4. From equation 4, n2 is equal to n1 plus m2 g cos of theta. n1 we already know is given as m1 g cos of theta. So we can say that n2 is equal to, substituting value of n1, we can write this as m1 g cos of theta plus m2 g cos of theta. We can take g cos of theta common. We can say that normal n2 is equal to m1 plus m2 into g cos of theta. So this will be the force exerted by m2 on the inclined plane is given by the formula n2 is equal to m1 plus m2 g cos of theta. So these were the 4 things which we were supposed to find out. Thank you.